Hello, class. This is Mr. Hart, and in this podcast, we want to start the chapter on plate tectonics. Okay, but before we can do anything with plate tectonics, we have to understand a little bit about the inside of the Earth. Okay, so we have to focus not so much on what's on the outside, where the plates actually are, but what's driving them on the inside. Okay, so we need to have a better understanding of the layers inside the Earth. Okay, if you remember back to like third grade, you probably learned a couple of the layers like the crust, the mantle, the outer core, the inner core. Okay, this is a very basic layout of the inside of the Earth. Okay, but we want to understand more. We want to go into more details because this is a very simplified version. Okay, that we learned in grade school. We want to understand more about these layers. Okay, so in class we watched a video by Khan Academy, which is a very good job of labeling the different layers of the Earth. And if you want to watch it, I highly recommend it at this YouTube link right here. Okay, but what he does is he goes through and he separates the Earth into two different sections, okay, or two different ways of thinking about it. So he calls one layer or one side the chemical or compositional layers, okay, and these are similar to the ones you learned in grade school, okay. So there's the crust, the mantle, the core. Okay, very basic layout. Okay, so everything in the crust layer has a similar chemical composition. Everything in the mantle layer has a similar chemical composition. And everything in the core has a similar chemical composition. Okay, very basic, only three parts on this side. But then he goes into much more detail in this section of what we call the mechanical layers of the Earth. Okay, this is probably new to you. Okay, so we can separate the layers of the Earth based on function, okay, or kind of the state that they are in. Okay, so the crust itself is not only just, it's not just one big chunk of crust. We can break it into different parts. Okay, we have what we call continental crust, where the continents lie, where most of the land is. Okay, we have the oceanic crust, which is where obviously the ocean lies on top of that. Okay, so we have two different types of crust, and underneath the crust we have what we call the lithosphere, which is a solid, rigid layer that all these different crust types are laying on. All the tectonic plates lie on top of the lithosphere. Okay, and so we have these kind of three layers combined: the continental, oceanic, and lithosphere that make up the crust. Now they're very similar chemically, but they have very different functions. Okay, mechanically they're very different. Okay. Then we have what we call the asthenosphere in the mantle, okay, which makes up the, it kind of is almost like a putty or a plasticky consistency. It's not quite a liquid, but it's not quite a rigid solid. But this allows heat to kind of ventilate through and move through this layer better than if it was just a solid, okay. Then we have what we call the mesosphere, which is a large chunk of the mantle, okay. And then we have the outer core and the inner core. Okay, and so if you watch that video, he goes into much more detail about the different parts and different sizes of these two sections, but we want to make sure we have this big picture down, okay, that we can think of the Earth in two ways, or the layers of the Earth in two ways, as the chemical layers, which are kind of the basic ones you learned, and the mechanical layers, which is these different sections that have more detail to it, have different functions, okay? So you should know this diagram by heart. Okay, the 3 chemical and the 7 mechanical layers. All right. So those are the layers of the Earth we want to know, and those will come into more. We'll understand these better as we move on and talk about plate tectonics, and we'll understand why we kind of separate them. But for now, you just want to know where they're at, know what they're like, and how big they are, so that we can think about these when they come up later in the chapter. Okay, so if we look at the different sections of the Earth, the different layers, we have 3 different types of rock, or 3 different types of compositions, right? So the crust is something we're pretty familiar to. A lot of it is kind of an igneous rock or metamorphic rock. You got a lot of minerals embedded into it. This is just a slab of granite, but you can imagine most of the crust is going to be very rich in minerals because of that heat that is cooled down as it is on the outer layer of the Earth. Okay. This rock is supposed to be similar to what the mantle composition might look like in the more solid regions. Okay, a lot more acidic gases and things like that. You get strange minerals that are forming because you have such intense heat. And then this rock actually isn't from the core, it's just from a meteorite, but it's what we guess would be similar to what the inner core would look like. Just very, very dark black mineral that is superheated because it's so hot in the core. Okay. But again, these are just kind of approximations to give you kind of an idea of what you might expect in those different layers. Okay? And so those are the layers. And one of the big questions we want to think about is, how do we know about the Earth's interior? How do we even have any idea what's going on the inside of the Earth? I mean, we can't even drill down more than maybe a good mile or two down into the Earth, right? We can't go very far into the crust. Definitely can't get to the core by any means. And so how do we know so much about the Earth? Okay. And it turns out we know a lot about the Earth's interior from earthquakes. Okay. So this is kind of cool of how they've been able to figure out where the earthquakes are. And it comes from where the layers are, and it comes from measuring the earthquake data. Okay. So seismic waves are the waves that earthquakes create. And when we look at seismic waves, they can only go through certain types of materials. Okay. Certain seismic waves can't go through liquids. Others can go through liquids, but they get bent as they go through. Okay, so if a P wave goes through a if a P wave goes through a liquid, it gets bent. Okay, S waves, which is another type of seismic waves, can't go through liquids at all. Okay, and so by looking at where these different waves are going, okay, some places we get more of a seismic wave than we would expect. In other places, we don't get any at all. Okay, so if an earthquake happened right here at this point on the Earth, we would see some more earthquake data right here for some reason, and we see a lot around here, but we wouldn't see any in this area. Okay, and so what they were able to do is by analyzing these different waves, you can figure out how much of this layer needs to be liquid, how much of this layer is solid, where are the different cutoff points, because you can do the math and a lot of geometry, some very crazy geometry, but you can figure out exactly where these boundary lines are. So that's how we know that the outer core, for example, is liquid, because we can see that these waves are bending as they go through. And that's how we know the inner core is solid, as they go straight through without bending at this point. And we can just look at all these different things that are happening and do all this, crazy geometry in computers and be able to figure out exactly how deep each layer is and how thick it is and what it's made out of. Okay? And again, we can analyze even more waves, the S waves, the P waves, the variations of those. And based on how they're bouncing and reflecting and refracting through different materials, we know exactly where these different layers are. Okay? And so just realize right now we're not trying to understand exactly how all this works. Okay? But we just want to understand that the reason they understand where the layers are is based on analyzing earthquake data. Okay? And so some crazy geometry and crazy math, but they will be able to figure out where the different layers are. Okay? Well, that's all we want to cover for this podcast. Let me know if you have any questions, and thank you for watching.